right, so last couple classes are up on YouTube. If you missed them, we went over a bunch of integration stuff and integration by parts. Today, I'm going to take a step back and we'll go through some free response questions. So I've pulled up all the ones from 2009 and we'll get through as much as we possibly can. Okay, so starting with this one, I've got Karen riding her bicycle along a straight road from home to school. She's starting at home at 0 minutes and arriving to school after 12 minutes. During the interval from 0 to 12, her velocity in miles per minute is modeled by this piecewise linear function above. And I want to find the acceleration of her bicycle at t equals 7.5 and indicate her units of measure. Okay, so if this graph is her velocity, then in order to get acceleration, I would need to derive this graph. So what I'm really looking for is the slope of this graph at the point 7.5. So that is the slope of this graph at 7.5, so right about here-ish. So in order to get the slope of that graph, I'm going to look at the change in y over change in x of this line in here that I'm marking in red. So my y changed from 0.3 to 0.2. So my change in y is negative 0.1. And then my change in x is 1 from 7 to 8. So my slope is dy over dx is negative 0.1. Okay, so I'm going to throw that up here. Okay, so my derivative at the point 7.5 could be estimated by my f at 7. I'm going to do f at 8. F of b minus f of a over b minus a. Okay, and then for units, I'm told that her velocity is in miles per minute. So if this is acceleration, this should be distance over time squared. So this will be miles per minute squared. Myself just a little bit more space there. And that's good. Okay, for part B, using correct units, explain the meaning from of the integral from 0 to 12 of vt if I take the absolute value in terms of Karen's trip, and then find the value. So if we just integrated from 0 to 12 without absolute value, that would give me displacement. But if I'm just looking for the magnitude of displacement, that will tell me the total distance traveled. So I could say the integral from 0 to 12 of the absolute value of vt dt represents the total distance Karen traveled from t equals 0 minutes to t equals 12 minutes. Okay, and then we need to find the value. So to find the value, I would need to get the area underneath the curve, and then if there's any areas that are negative, like this area from 2 to 4, I would need to make that positive. Okay, so I'm gonna recapture this FRQ really quick so I can make our picture just a little bit bigger, and we'll go find the areas after that. So take a new screenshot here. of just our chop part. Okay. So if I want to find these areas, I've got a couple different regions I'm going to shade in really quick. So here in blue is my first area, and then in yellow is our second. I'm going to make a third area here in green. And we'll make another one in yellow and blue. Pink and orange, why not? Okay, so if I want these areas, my areas for a triangle are 1/2 of base times height. So this is 1/2 of 2 times 0.2. 2 times 0.2 is 0.4. 1/2 of that is going to be 0.2. So this area is 0.2. This area is the same triangle, so negative 0.2. This area in green is another triangle. I've got a 0.3 by 1 triangle, so this is going to be half of 0.3 or 0.15. I've got a 0.3 by 1 triangle, so this is 0.3 for my yellow value here. Then I've got each one of these squares is 0.1 times 1. So this is 0.1, 0.2, and then half of 0.1. So this is 0.25 total for the blue. So I'm going to stick down here. In pink, I've got 6 of these squares, so that's 0.1 times 6 is 0.6 for my area here. And then I've got another triangle, so this is 0.2 times 1 divided by 2 is 0.1. Okay, so if I want the total distance traveled, I'm going to need to add up all of these areas, but make them positive. So if I add all of this up, I'm going to go ahead and use a calculator here, since the first 2 questions are with calculator. This is 0.2 plus 0.2 plus 0.15 plus 0.3 plus 0.25 plus 0.6 plus 0.1 is 1.8. So my total distance traveled will be 1.8 miles. So I'm going to copy this part here. Nope. Let's flatten that first. Okay. Okay, so I could say that this integral is equal to the sum of all of my areas which ended up being 1.8. And I do need units for this. So if I was in miles per minute for velocity, when I integrate I should get a distance. So I integrated with absolute value, which is the total distance traveled. So this is 1.8 miles. Okay. So then shortly after leaving home, she realizes that she left her calculus homework at home and she returns to get it. So I want to know what time she turned around to go back home. So if this is her velocity, whenever this graph is positive, so for all of this blue section here, the graph of velocity is positive because the y value is positive. And then for that yellow section, the y value turns negative, so she changed direction at t equals 2. So I could say Karen changes direction. Actually, it's past, so Karen changed direction at t equals 2 minutes. As our velocity from t equals 0 to t equals 2 is positive, but from t equals 2 to t equals 4 is negative. It's kind of cool. You can actually see on the graph she has no velocity from 4 minutes to 5 minutes. So she wasn't making any progress towards school or away from school. That means she was at our house trying to find her calculus homework. Alright, so that should work as far as a reason for our answer. I imagine if we actually look at the scoring guides, they'll have something that looks more like this. Should say v at t is greater than 0. Maybe on the interval from 0 to 2. And v of t is less than 0 on the interval from 2 to 4, which means the same thing. Okay, last part. We're told there's another guy, Larry, who also rides his bike on a straight road from home to school in 12 minutes. His velocity is modeled by this function wt is equal to pi over 15 sine of pi over 12 times t, where wt is in miles per minute for 0 to 12 minutes. And they want to know who lives closer to the school, Karen or Larry, and then show the work that leads to your answer. So if I want to figure out how far it is to school, I can't just use this 1.8 because Karen turned around. So she has extra distance that we don't actually need. So what I'm going to do is I'm going to get her displacement from 0 to 12 instead. So that's when she left home for the first time to when she arrived at school. That displacement should tell us the distance from the start point. So we're going to integrate from 0 to 12 of both of our functions. So that's our v of t that we were given here, and also our new wt that we were given for Larry. But we're not going to take the absolute value this time. Okay, so if I don't take the absolute value, this would look something like this. For our picture, everything stays the same except this negative 0.2 needs to become negative. So I'm actually going to copy this whole equation, and we'll just change that positive 0.2 to a negative 0.2. Okay. So if I added all of this up now, I took away I took away 0.2 and then I subtracted a 0.2. So really we traveled 1.76 miles total. Okay. So this is this is Karen's displacement. From home to the school, which should tell us the distance from her house to the school. Okay, and then I need to do the same thing for Larry. So Larry's a little bit more straightforward. I could say Larry's displacement from home to school would be equal to the integral. Oops. I need bounds. Okay, it would be equal to the integral from 0 to 12 of Wt. So what I'm going to do is I'm going to plug in that Wt into my calculator, and we'll integrate directly. So I've got up here in my equations, I'm going to copy this pi over 15 times the sine of pi over 12t. Okay, then I'm going to double check that I'm in radians really quick. I am in radians. So then we'll integrate that directly. So I'm going to hit math and scroll to integrate. So I need equation, variable, lower bound, upper bound. So for my equation, I'm going to hit variables, function y1, and that'll paste our equation in there. I'm integrating in terms of x from 0 to 12. Okay, so Larry's displacement from home to school is 1.6 miles. You put that back inside our function here. So that means that Karen's distance is further. Okay. And that's it for the first one. I know you guys just... I would take questions, but I don't think anyone has a working mic. So if you've got questions, just write them down, and we can bring them in the next time that we come. Alright, so I'll move down to the second one. So for the second one, I have a rock concert going on. We've got a rate at which people are entering the rock concert is given by this function, R of t, measured in people per hour. No one is in the auditorium at t equals 0 when the doors open. When the doors close and the concert begins at t equals 2. So the first thing they want to know is how many people are in the auditorium when the concert begins. So the concert begins at time equals 2. So I could say the amount of people that joined before 2 would be the amount of people in the auditorium when the concert starts. So that would look something like this. If I integrate from 0, that's when we open the doors, to 2 when the concert starts, of R of t, that's a function in people per hour, then we'll get the total number of people that came in between hour 0 and hour 2. So that should be, to find this really quick, this is the total number of people in the auditorium when the concert begins. Okay, and again we are in a with calculator section, so I can actually just plug this in and integrate. So let's go ahead and do that really quick. Okay, got a message from somebody, but I don't see anything. Okay. Okay, Yu Jung, just got your message. Can you hear me? Okay, cool. Alright, so we've got the total number of people in the auditorium when the concert begins is equal to the integral from 0 to 2 of RT dt. So we're going to plug that into our calculator. I've got R of t is equal to this, so let me clear out this one from the last problem. I've got 1380 t squared minus 675 t cubed should be my R of t. And I want to integrate that from 0 to 2. So let me quit out and we'll do math integral of our variables, y variables function y1, and then I'll plug in our function that we just typed. In terms of x, from 0 to 2. It gives me 980. So I could say, just copy this part. That integral is equal to 980. So there were 980 people total in the auditorium. All right. Okay, I can see your chat then, so if you guys have questions, just type them into the chat at any point. Okay, so the next thing I want to do is find the time when the rate at which people entering the auditorium is at a maximum, and justify the answer. So in order to maximize the number of people in the auditorium, I would need to look at the first derivative. That first derivative is actually my rate at which people are entering the auditorium, which is what was given to us. So that's r of t. Whenever r of t is equal to 0, that's a point where we could have either a maximum or a minimum. If my... Okay, whoa, that is huge. Okay, let's crop to a little piece of this. Whenever my slope is equal to 0, I could have a maximum for my function, or I could have a minimum, which would look like the opposite of that. Okay, so what I need to do is I need to figure out when the slope is equal to 0, and then I've got an option. I could either take a first derivative test, which is test points around that slope of 0 to see am I changing from increasing to decreasing. Or I could derive the function at that point and see am I concave down like this, which would mean I have a maximum, or am I concave up, which would look like this one. If I'm concave up with a slope of 0, that would have to be a minimum. If I'm concave down with a slope of 0, that would have to be a maximum. Okay, so I think I'm going to do a second derivative test. So we'll set this equal to 0 and solve for x first. So I could say, first thing I need to do is set r of t equal to 0. So we'll figure out when the slope is 0. 0 equals r of t. So I could say 0 is equal to this. 1380 t squared minus 675 t cubed. Okay, so if I factor out my t's, oh, it should be a negative. There we go. I'll have this. 0 is equal to t squared. Times 1380 minus 675. I think I could divide by 5 at least. I might be able to do more than that. If I do 75. Okay. Again, so I'm going to pull a 5 out too. So that was 5t squared. Times 276 minus 135t. Okay, so I've got 2 points where the slope is 0. The slope could be 0 at the point 0. Or I could set 0 equal to 276 minus 135t. And say that t is equal to 276 divided by 135. Okay, So assuming that my maximum is not 0 because we had no people in the auditorium in the beginning, I'm going to derive this equation to take my second derivative and then plug in this point. If that second derivative is positive, that means this is a minimum. If that second derivative is negative, then that means we have a maximum. So I could say my derivative of r at that point, 276 divided by 135, should tell me whether this is concave up or concave down. So let me do that really quick. I'm going to derive our function y1 in terms of x at the point 276 divided by 135. And I am negative. So at the time, 276 over 135. Which is measured in hours. After the door is open, the rate at which people are entering the auditorium is at a maximum. Okay, and check my answer really quick, make sure we got that right. 1.36. 2.04. No. Okay. Uh-oh. Okay. So I made a mistake because I read this question wrong, actually. We're not looking at when the number of people in the auditorium are maximized. We're looking at when the rate at which people are maximized. Okay, so that actually means I want to maximize R of t, not maximize the number of people. Okay, so if I want to maximize R of t, then I need to set the slope of R of t equal to 0. Which means we actually need to redo all this. So I'll do this. Okay, if I set the slope of R of t equal to 0 and solve for x, I'll get this.
So Brendan,
Yes.
my connection is so bad.
Okay, I can't do much about the connection. If you want, I can post the video afterwards so you can catch up on everything. Let me... Okay, I'm going to send the PDF with the questions. That way you can see everything, even if the connection is bad, okay?
Thank you.
So let's do that. Okay, so that should be up in the chat. Okay. And then at the end, I'll post the document we're working on too.
Thank you.
Okay, so we are on 2B. I'm finding the time at which the rate at which people entering the auditorium is maximized. So I'm going to set the slope of this function equal to 0 and solve for our time. So let me go ahead and derive this function really quick. I've got 0 should be equal to 2 times 1380 times t minus 3 times 675 t squared. could factor that out too. So this is 0 is equal to t times this. Let's multiply this out too. Okay, so that gives me 2 times again. So either t could equal 0 or t equals 2760 divided by 2025. Okay. So let me go up into the calculator really quick, and I think I'll do a first derivative test this time. That way we don't have to derive this again. So if I plug in if I plug in r of 1, prime at 1. If I plug in r prime at 1, will this slope end up being positive or negative? Okay, I've got a t on the outside, so this will be 1 times 207.60 minus 2025 times 1. So that should be positive. If I do r prime at 2 instead, will that be positive or negative? Into this part.
Positive.
Um,
Negative.
Okay, it's going to be negative. Okay, so I'm changing from positive to negative. So is this a maximum or a minimum if I'm changing from increasing to decreasing?
Maximum.
Maximum, cool. So I could say, therefore, the rate at which people are entering the auditorium is maximized at the time um, 2,760 over 2,025 hours after the doors open. Okay. For the next one, I'm told that the total wait time for all the people in the auditorium is found by adding the time that every person waits, starting at the time that the person enters the auditorium and ending when the concert begins. WT models their wait time for all the people in the auditorium before time t. The derivative of W is 2 minus t times r of t. I want to find W at 2 minus W at 1, which would be the total wait time for those who enter the auditorium after the time t equals 1. Okay, so if I want to find W2 minus W1, what I could do is I could integrate this W prime of t that they gave us. So that would be something like this. W2 minus W1 is equal to the integral from 1 to 2 of W prime t dt. If I integrate this function, I would end up plugging in my upper bound and then subtracting my lower bound. So it'd end up getting W2 minus W1. Okay, so then I just need to plug that into the calculator. We should be alright. So I've got RFT still saved in my calculator here. If I scroll back up, RFT was 1380 t squared minus 765 t cubed. So I've got RFT in the calculator already. So to get W prime of t, I'm just going to multiply this R of t times 2 minus t inside my integral. Okay, so I'm going to break out of this, and we'll integrate. Our R of t, so that's R of t, times 2 minus t, in terms of t from 1 to 2. Okay, and I have 387.5. So now only 1 hour passed, but collectively, if you were to add up all of the time that the people who entered the auditorium at 1 hour before it started to the time when the concert started, you would get 387.5 hours of time waited. So I'm going to write it like that. There were 387.5 hours of time collectively waited for the show to start. Even though every person really waited for less than an hour. Okay, last question. On average, I want to know how long the person waited in the auditorium for the concert to start. And I want to consider all people who entered the auditorium after the doors opened. And then use the model for the total wait time from part C. Okay, so if I want all people who entered the auditorium from the time the doors opened, then instead of integrating from 1 to 2, I want to integrate from 0 to 2 to get the total amount of time collectively waited. But if I want an average, then I would have to use our average value formula, which would be this. Average time waited is equal to, I've got 1 over b minus a, so that's 1 over 2 minus 0, times our integral, from 0 to 2, of w prime of t dt. Okay. So this is the average time that we've collectively waited. That's not actually what the question's asking for, though. The question wants how much time did a person actually wait in the auditorium. So I think we need to divide that by the number of people that we have in the auditorium from 0 to 2 on average. So this is the average time waited collectively. Then I also need the average number of people in the auditorium. Which would be one over b minus a times the integral from A to B, so from 0 to 2, of R of t dt, which is the rate at which people are coming into the auditorium. So that'll tell us how many people are actually in the auditorium at that time. So this should give us an average number of people in the auditorium. If I take the average time weighted and then divide by the average number of people, that should give me the average time per person that people are waiting. So I need to divide these two things together. Okay, so that would give me this. Average time weighted per person is equal to the fraction of both of what we just wrote. So this divided by this. Okay, so now I just need to get these values. So last time I integrated WT from 1 to 2. I'm going to go back and hit that same entry, and we're just going to change our time from 1 to 0. So I'm integrating R of t times 2 minus t in terms of t from 0 to 2, which would give me this integral from 0 to 2 of w prime t. Then I'm going to divide that by 2 because I'm multiplying by 1/2. And that should give me the numerator. So that was 280 hours. Okay, I want to divide by all of that. Let me just keep this on top for now. 280 hours. And then on bottom, I need to integrate R of t. So that'll give me the integral of our function RT from, in terms of x, from 0 to 2 is 980. And if I divide that by 2, there's an average of 490 people there. So my average time weighted per person then would be equal to 280 divided by 49, or 28 divided by 49, is 0.5714 hours per person. Okay. Any questions on what we did for the last one?
So for the first question, okay, is
First,
the mean value?
so this is actually average slope. So mean value theorem guarantees that there will be one point between our start point and end point where the slope is equal to the average slope between them. So mean value theorem has the equation for average slope as part of it.
Okay.
But what we were looking for was just what was the slope of this line from 0.7 to 0.8. So very similar, but the purpose is different.
Okay.
All right. Okay. I think we've got time for maybe one more. Preview really quick. I've got one that looks like disk and shell method, one that looks like, okay, we've got some Riemann sums and secant line, tangent line stuff. One that is graphical integration, and one that is really just integration. What do you want to talk about?
왜 일어났어?
Riemann sums? Okay. So I'm going to skip down to question 5. So question 5, we have this table, and we're told that f is a twice differentiable function for all real numbers. The first thing they want us to do is to estimate the slope at x equals 4. Okay, so I don't have a point for x equals 4, so how could I estimate the slope? Okay, I'm gonna zoom in, so hopefully this will be easier to see. Okay, we don't have a function, we just have a table. So how can I use these points to estimate what the slope would be at 4? Okay, I heard a sound that sounded like you got it, but I've actually lost your video. So what I can do is I can get the average slope between the points at 3 and 5. So that would be y2 minus y1, or f of b minus f of a, f of 5 minus f of 3, over b minus a, 5 minus 3. Should give me the average slope between those 2 points. So that gives me negative 2 minus 4 over 2, or negative 6 over 2 is negative 3. Okay, and the next thing we need is the integral from 2 to 13 of 3 minus 5 times the derivative of f of x, and to show the work that leads to the answer. Okay, so if I do this really quick, I've got the integral from 2 to 13 of 3. And I'm actually going to split this integral up into a separate one, so I think it'll be easier to solve this way, possibly. So if I split this up, this is the, minus the integral from 2 to 13 of 5 times f prime. Okay, you Jung, you okay? Okay. So for my first integral, if I integrate this, I'm just going to be multiplying. So 3 times my x for my upper bound and lower bound. So that is 3 by 13 minus 3 by 2. Okay, then I'm going to take whatever that answer is and subtract whatever I should get for this integral. So for this integral, I can actually pull this 5 out too, so let me go ahead and pull that 5 out. This might be easier. Okay, if I integrate this, I'm going to get 5 times my integral of f. So that's 5 times f of my upper bound, 13, minus 5 times f of my lower bound, which is 2. Okay, so now I need f of 13 and f of 2. So I'm going to zoom out just a little bit so I can see the table. So I have f at 13 is 6, and f at 2 is 1. So I can substitute those values in. So this is 3 by 13 is 39 minus 6, minus, I've got 5 times f at 13 was 6, minus 5 times f at 2 was 1. Okay. So that gives me 33 minus, this is 25 minus 5, is 20, is 13. Okay, any questions on A or B? Nope, okay. In part C, we need to use a left Riemann sum with subintervals indicated by the theta in the table to estimate the area from 2 to 13 of f of x, and then show the work that leads to your answer. So for this one, I'm going to copy our sheet again so I can make it a little bit bigger. Okay, a little bit bigger picture for our table, and we'll show you what's going on with the Riemann sums here. So I want left Riemann sums. Okay, so left-hand Riemann sums would look something like this. I'm going to have one rectangle that goes from 2 to 3. Another rectangle from 3 to 5, another one from 5 to 18, then another one from 8 to 13. The heights of those rectangles will have to come from the left side. So the height of my first rectangle is 1, and then my base is 1. That's my distance from 2 to 3. The height of my second rectangle is 4. And my base is 2. That's my distance from 3 to 5. Height of my next rectangle is -2. With the height, with the base of distance from 5 to 8 is 3. And then for the next rectangle would be height of 3 with a base of 5 is my distance from 13 to 8. Okay, so really what I've got looks like this. If I multiply those base and heights together, I'll get my areas. So my areas are 1 times 1 plus 2 times 4 plus -2 times 3 plus 3 times 5. So that should give me, this is 15 minus 6 is 9, plus 1 is 10, plus 8 is 18. Okay. Any questions on what we did for the Riemann sum? Nope. All right, last one. We're told that the derivative at 5 is 3, and we are concave down on the closed interval from 5 to 8. I want to use the line tangent to the graph of f at x equals 5 to show that f at 7 must be less than or equal to 4. Okay, I'm going to stop there. We'll do the second part after that. So if I know that we are concave down, then my graph should look something like this. So if I'm concave down, I would be curving down like that. Um, and that is from 5 to 8, where we moved from -2 to 3. So I was increasing, and if my slope was 3, then I was increasing the rate of 3. Okay, so then I need a line tangent to the graph of f at the point 5. So to get an equation of a tangent line, I need a point and a slope. So I have my point at x equals 5 is 5, -2. And my slope, I was told, is 3. So my equation of the line could be y minus my y value, which at 5 is -2. So y minus -2 should be equal to my slope, 3 times x minus my x value, which is 5. Okay, so that's my equation of the line tangent to the curve at the point where x is 5. If I had a line tangent to the curve, we'll say this is 5 at this point. It could look something like, it could look something like this. As long as we are concave down, if I use that line to estimate, what's going to happen later on. So at x equals 8, then that tangent line should give me a value that is above the curve, above our actual function. If I kept extending this black line out, something like this, my y value for the black line is going to be much higher than my y value for the red line, right? Okay, and that only worked because we know that the function is concave down from 5 to 8. So if we can figure out what the y value is for the tangent line, that's the black line, when x is 8, that should, our value of the red function, the actual function, should be less than that. Okay, so I'm going to use this tangent line, and we're going to change our x value to x equals 8. And that will give us an overestimate. Okay, so my equation of the tangent line is this. Simplify this really quick. This is y plus 2 is equal to 3 times x minus 5. So if x equals 8, then the line tangent to x equals 2f at x equals 5 is this. And the y value is what happens when I plug in x equals 8. Okay, so I'm going to solve for y. So if I solve for y right now, after plugging in x equals 8, I've got 8 minus 5 is 3. 3 times 3 is 9. And 9 minus 2 is 7. I'm supposed to show that f of 7 is less than or equal. Okay, I went a little bit too far. I was supposed to only go to 7. So I'm going to walk back. I want this to be x equals 7 instead. Same principle, I just plugged in the wrong number. So this is, if x is 7, 7 minus 5 is 2, 3 times 2 is 6. And then 6 minus 2 is 4, so this is y equals 4. Since f is concave down from 5 to 8, the y value of the line tangent to our function at x equals 5 should be greater than or equal to the y value of the function. All right. And last thing we have to do today is the second part of this. So write out what we just proved really quick. Therefore, f at 7 must be less than or equal to 4. Okay, use the secant line for the graph of f on 5 to 8 to show that f of 7 must be greater than or equal to 4/3. Okay, so our tangent line had to be bigger than the actual function. But if I drew a secant line, okay, we leave that as black. If I drew a secant line from where we were at 5 to another point, the secant line should be below where we are. So either below or equal to. I'm looking for what is the y value when x is 7. So that secant line should underestimate it. Okay, so if I do that, the equation of my secant line then would be the line between 5 and 8. So I need a point and a slope. So secant line, I need the slope first. The slope of my secant line between 5 and 8 is going to be the average value here. So that's f of 8 minus f of 5 over 8 minus 5. Okay. Okay. So f at 8 was 3, f at 5 was negative 2. So this is 3 minus negative 2 over 3 is 5/3. So I've got the slope of my secant line and I've got the point. So I could pick either one of these points on the secant line, so I'm going to pick 5, negative 2. So this is equation of the secant line would be this. Y minus negative 2 is equal to 5/3 times x minus our x value at 5. Okay, and the last thing we need to do is prove that f of 7 is going to be greater than or equal to 4/3. So I'm going to plug in f of 7. So this is y plus 2 is equal to 5/3 times x. X minus 5, or x is 7, so this is 7 minus 5. I've got 7 minus 5 is 2, so this is 10/3. So y plus 2 equals 10/3. If I do 10/3 minus 2, 2 is 6/3, so 10/3 minus 6/3 is 4/3. Okay. As our graph is concave down, the y value should be less than or equal to the secant line between 5 and 8 when x is 7. So what we just proved was f of 7 must be less than or equal to 4/3. Oh, must be greater than or equal to, sorry. Greater than or equal to. Whew. Okay, we are 6 minutes over time, so I apologize for keeping you guys a little bit longer. Let me post all of our answers up to the Skype chat, and we'll cut out there. But thank you guys so much for coming. If you had any other questions on any of the ones we didn't get to, just let me know when you come to class on Wednesday. And I hope you enjoy the rest of the break. Catch you guys later.
Thank you.
Goodbye.